If my bone is primarily made out of calcium, and my body needs calcium for lots of other sources, for things like neurotransmitter release, muscle contractions, we need to be able to move calcium in and out of the bone and regulate the calcium to make sure that everything in our body is functioning correctly. There are a few hormones that I want to make sure that we are able to look at and see how they impact the bone, but impact the body as a whole to regulate our calcium levels. So there are two global hormonal regulators. We have parathyroid hormone, and this one's going to be released when there is not enough calcium. And then there is calcitonin, calcitonin, which is released when there is too much calcium. There is a third hormone off to the side, calcitriol, which is going to help us with absorption. Okay, and we'll talk about that hormone later. Let's start with not enough calcium, right? So if I don't have enough calcium, I'm not able to do my muscle contractions, not able to release neurotransmitters. I need enough calcium. So what is my parathyroid hormone going to do? My parathyroid hormone, or PTH for short, is going to have three kind of major areas that it works. Okay. The first area is it's going to go to the bone. It's going to tell the bone to release calcium, primarily through the actions of osteoclasts, which again break down bone. Now, it's not going to break it down in such a way that your bone is suddenly going to fracture unless you are keeping up with this parathyroid hormone longer and longer and longer and longer. Where it's also going to work is it's going to work in our intestines to tell us to absorb more calcium from our diet. Right? Because again, we eat all of our food, gets to our intestines, and we're going to absorb food from our intestines at sort of a variable rate, and hormones like parathyroid hormone can help improve that. The other big area, and probably where it has a bigger role, is in the kidneys. And it has two functions in the kidneys. The first function is it's going to tell it to create calcitriol, or vitamin D, which I talk about in another video. Calcitriol is able to tell the intestines in a more direct way to absorb more calcium from their diet, and we can bring that in better. It's going to help with the actual absorption process. The second thing that it's going to tell the kidneys to do is to decrease the calcium excretion from our kidneys. Okay, so we're peeing out less calcium, and we're absorbing more calcium as well. So it's going to regulate the transport mechanisms to make sure we don't pee it out, but we also bring as much in as we can. So that's all the ways that by doing that, all three of those systems can allow for us to increase the calcium over time. Calcitonin works somewhat opposite. So calcitonin, when we're thinking about the three areas, okay, for a long time, we wondered if it had any osteoblast activity, right? Because if we're trying to build up our osteocyte activity. And really, we don't see a whole lot with that. We don't see us building up bone. We're not absorbing more calcium, right? We don't need more. We had enough. And so instead, it's mostly going to tell the osteoclasts to calm down. But where it really shines, where calcitonin does the most of its work, is going to be in my intestines and in my kidneys. So in my intestines, I'm going to decrease my calcium reabsorption. And in my kidneys, I'm going to make less of my vitamin D, or calcitriol as we call it. And we're going to decrease reabsorption increase secretion and excretion. So it's somewhat opposite, but we're more focused here on the intestines and kidney as opposed to the bone. I hope this helps with understanding